Our teacher, he is Balasurya. He is our MLPTA for the term May 2024. Thank you.
Right, thanks. Okay. Okay, can I start, Abhinesh?
Yes, sir. You can go on with your session.
Thanks. Uh, so hope my screen is visible.
Yes.
Perfect. So I have few plans on this particular revision to go with. So do anybody have anything that we need to stress upon, or uh, do you want any clarity on this particular topic, or any sort of that thing is needed? Mhm. Anybody? Any doubts to start with? Anything that you want to stress upon? Anything like that? Okay, then let me go with my uh, way of presentation. So I'll just summarize what will be there in your MLP. It is mostly theoretically it is very low. I mean, it is not heavy basically. So uh, it is mostly programmatical. So it is just you need to learn with the uh, documentation. Mostly go with the documentation for everything. So anyways, I'll just summarize what is there in this particular course. So so in week 1 to 4 we'll be having pre-processing. So mostly this 4 weeks completely focuses on pre-processing. Mostly I don't have, there are other things also, but mostly it is pre-processing. uh, so in pre-processing, what are the things that will be taken care of? Starting with EDA, which is exploratory data analysis, where all the charts will be discussed over there, where you have learned Seaborn, Matplotlib, all those things will be there, all kind of charts, plots, and yeah, all those things will be there. And next comes the pre-processing, where we actually do data cleaning. Basically, once you load the data, so loading will also be a part of this particular course, and load the data. And once the data has been loaded, what we'll be doing is we'll clean the data. So there will be null values which we'll be imputing, and then once it imputing comes for null values, once it is imputed, uh, we'll this is for the numerical things and also categorical also. So once categorical and numerical are imputed, we'll go with encoding. So what encoding does, like as you know, sorry for my handwriting, I'm very new to this particular. Uh, it's been long, I should say. Uh, Encoding, where encoding you'll be converting all the categorical variables to numericals, right? So that is where encoding comes in. Once imputing and encoding is done, we'll be doing scaling. Uh, so scaling, there are types of scaling that will be discussed. Comes with standard scalar, robo scalar, and there are a lot of min-max scalar, max absolute scalar. I'm not going too deep into these topics because week 1 to 4 will be a very light-weighted topic, because there will be no much questions asked in your end terms. So I'll be focusing on the last few weeks, which is 9 to 12, 9 to 11, I guess. So mostly focusing on that. But for completion's sake, I'm just introducing and summarizing what are there in this particular thing. So I'm not solving any problems on this 1 to 4 and all. Okay, I'll just go as a completion part. So scaling is done, and once scaling is done, what else? So standard scalar, almost everything is complete. Any other things that is left? No, scaling. Yes, all. I guess that's it from my side. Yeah, for week 1 to 4, that's it. Once scaling is done, we'll go with the model building. So once model building comes, there are two types of models that we'll be building, mostly this particular course, which is regression and classification. And classification. So mostly this is all for week 1 to 4. So, any doubt on this particular week 1 to 4? Any particular topic you want to discuss? Anything? If at all not there, I'll just go to the week 4 to 8. Actually. So yeah, I'll just go to week 4 to 8 now. Uh, so week 4 to 8. So this particularly focuses on, this is the most important aspect. I mean, most important part of this particular course, where we'll be doing all kinds of model building, and all kind of models from sklearn will be discussed in here. All sort of regression, classification models, all those things will be discussed. So yeah, logistic regressions. So I'm not going any deeper in this particular topics, because it is kind of like very less questions will be usually asked in this particular week till 8, and mostly not even 50% will be asked till 8%, 8th week. So all those logistic regression, SVMs, what else? Uh, What's a prompt? Mostly decision tree will not be covered in this particular week. All those basic models preparation, dummy classifiers, dummy regressors, uh, linear regression. So all those kind of topics will be covered over here. And KNN imputations, sorry, KNN model building, which is also being taken care of in this particular week. Uh, this clustering techniques, all those things will be there, I guess. And yeah, so week 4 to 8 also covers only these parts. Again, if at all anything needed, and SGD uh, regressors and classifiers. So all these aspects will be taken care of this particular, and this is one questions mostly people will be asking on these SGD regressor. How do you convert this into a lasso? How do you convert this into a perceptron? So you need to change the parameters accordingly to convert the SGD. SGDs, regressors, and classifiers are common way of doing any kind of models. So you need to learn about these parameters. Basically, you can go through it. You still have 1 week of time. You can refer to all the SGD. I mean, all the uh, documentation for this particular thing. I'm not, again, if at all needed, if anybody asks, I'll just go through this, or else I just leave. And uh, then there are a lot of these are loss techniques based on which uh, these particular SGD is being converted into. It is a flexible model which can be converted according to the other needs. So that is how this particular thing is. I hope I'm, yeah. Yeah, now we are actually going deep into the end term particular thing. End term, as far as the end term revision is concerned, we'll be going with week 9 to 11, which is quite advanced topic. Not advanced, but somewhat. Once you are clear with till week 8 only, you can focus on week 9 to 11. So where you'll be ensemble techniques will mostly be discussed. What is ensembling, I'll get into it later. So this is one thing that we'll be discussing. And next comes the error and scoring metrics. Error and, sorry for my handwriting, scoring metrics. So these are metrics on which the particular model is being covered. And this is there. And MLP, which is also kind of ensembling technique. But MLP is also a part of this particular 9 to 11. And yeah, I'll just check. Is there any other thing? Since I've said ensemble techniques, almost every other aspect has been covered. So I'll just go directly dive into the ensemble techniques. So what is ensemble technique? So um, till week 8, we'll be till week 8, we'll be using one models only. One models, uh, fitting it, predicting it, only one model. Whereas in any ensemble technique is a kind of merging of few other uh, two or three models. So if you say voting regressor, basically, so any it is one kind of ensemble technique where you'll be there is something called estimators where you will be using three, or I'm just saying as three. So out of three models will be trained uh, parallelly, and then out of these three models, output of these three models will be used for prediction. So there are two types of voting regressor as well. I'll just come a little deeper to it later. But before coming to that, I'll just inform, like I'll just say what voting models is. I mean, ensemble models is, where three models has been trained on different sets of data or same set of data. So there is something called bootstrap that we'll be seeing it later, where uh, and data set X is randomly sampled and trained, randomly sampled and trained these three models. One will be trained upon different set of data, and three models will be different, have different set of data. And there is kind of a bootstrap technique. If it is false, then it is kind of it will be done with replacement, and if it is true, it will be. I mean, if it is true, it will be done with replacement, and if it is false, there will be no replacement at all. So yeah, so all those things will be there. So that is where ensemble techniques, the power of ensemble technique is, we are not relying upon a single uh, particular single model. So uh, it will be easy for us to predict. It is a quite unbiased technique, or it is a kind of where you learned this kind of, what is it, uh, bias variance trade-off. So all those things will be taken care of with this ensemble techniques. So yeah, starting with the decision tree. So this is one important uh, ensemble technique that will be discussing upon, decision tree. So how do you want to learn? I'm so sorry for my handwriting. It's very bad. Yeah, before going here, do anybody have any doubt till what I've taught? Anybody? I'll just have a stop over here. Yeah.
Guys, if you have any doubts, please ask.
Yeah. Okay. So do you have any
You
questions on
can
any,
carry on.
yeah, any previous question that if you need to answer, if you have any doubt in that, please do ask me. I'll just solve it here only. So yeah, coming to the decision tree. So there are two types of decision trees, which is regression and classification. So I'll just I don't know how well I could go with some kind of theoretically, because mostly it will be, if you have any questions only I can answer, because or else I'll just go with the parameter explanation. So how decision tree works? There will be set of data where data based on the features, it will be splitting the nodes. So if it is a single tree, it is a decision tree. So okay, if it is a group of trees, then it is a random forest. So I'll just focus on decision tree for now. So based on features, there are different set of features at every node, different or same. It depends, and there will be nodes on which the, I mean, based on features, it will be splitted. Say an X contains 1, 2, 3, 4, 5. So I'm just saying, and why there's um, 10, 11, 12, 13, 14. So in X, if I want to use this particular thing, I mean, I'll just go with X1 and X2 itself. X1, X2. So X1 less than 3. So all the first, these 2 points and these 2 points will be taken over here. True and false, and depends, anywhere it can be. 1 and 2 can come here, 10 11 will also come here, because as far as x1 and x2 we are considering x1 here, and in x2 there is no uh, division for here. So, and similarly less than 3, so other 3 4 5 will come here, and 12 13 14. Yeah, and x2 if I have here less than 12, right? So all these will be split over here, and again in this node we have some kind of, oh, I'm just leaving the box. So something similar to this, and again there will be splitting based on the nodes, based on some conditions. Oh, based on some conditions there will be splitting of nodes. Okay, do tell me if my handwriting is very bad. Well, they'll just go. So what is this based on? So we have control on this node splitting also. So I'll just say what are the parameters that we discussing upon. There are many things which is the most important, most asked is the max depth. So here in this particular thing, the depth was 2. Depth was 2. The depth was 2, which is 0, and this is 1. And depends and starts with 0. So we can set the depth. So whatever the depth is, till then, if I set to 3, until 3, it will be splitted, and the prediction will be based on that. And yeah, here there will be labels concerned. I'm not going again deep into this particular thing. There will be labels. So there is something called criterion where we'll be using labels as an index. How many pure? So our aim is, if it is 0 and 1, I want to classify it as pure nodes. So if it is a pure node, everything in this particular node should be 0. If everything in this particular node is belongs to class 0 and everything belongs to here is 1, then it is known as uh, pure nodes. The node is very pure, such that anything there is being. Yeah, I'll just, yeah, recommendation system and time series. Yeah, I'll just touch upon it if time permits. So max depth. Yeah, but mostly questions will be asked on this time series and recommendation systems. Basically, the questions will itself be very low as far as the previous courses is also concerned. These are very important. Basically, if you are thorough with this, it will help you in your later courses as well, even in your degree levels. So yeah, make max depth is that. And coming to this, what else? So min sample split. So min sample split, it as it suggests, if it is 10, until unless the node contains 10 values, it won't be split. So the node should at least have 10 values to split. And min leaf split. So as the name suggests, it is again, if at all, out of if the leaf contains, like I'm having 8. So if at all this particular thing is split, it should at least, the leaf should contain at least 8 nodes, 8 split 8 would, values in this particular node, unless and otherwise it won't be splitted. So we can control all these. We can set values for this, and yeah. So there are many other things, and we can, based on criteria also, we can split. There is criteria, which is Gini, entropy for classification. So all those things you can. There are, you don't want to know how Gini and entropy works, but you at least need to know how there is, what is for regression and what is for classification. These two belongs to classification.
Excuse
And
me, sir.
yes.
Do we need to know the code aspects better or the concepts better? Like,
Uh,
which part should
uh,
we focus on?
so as far as the end term is concerned, you need to go with the uh, concepts only. Concept meaning like there is a balance in the question paper also. So you need to know the coding part, but there will be kind of um, uh, coding. So the questions will be based on coding only. So even if you know coding, you can answer theory. If you know theory also, you can answer coding. So it will be some kind of alternative vice versa behavior only, because there will be given set of code, and you need to classify which part of the code is correct and which is not, and what is the parameter that you need to fill. So if you know the concept, if I say set a regularization rate, so you need to know that regularization rate is alpha. So, and in programming it is set as alpha. So you just need to know what is the regularization rate and what is alpha is. And you know what is C? Whoever asked, do you know what is C?
Yes, it's the inverse of
Yeah, inverse of
regularization.
regularization rate. So you just need to know what is the inverse of regularization rate and what is C. So that is more than sufficient as far as n term is concerned. It will be given, and you have options also. You can go with it. So yeah, so something similar to this you need to know. That's it. Yeah, and coming to this, one other point is decision tree bones for overfitting. So it overfits basically. So it overfits most probably. So overfits. So if it is overfitting, what is the thing? It has high variance and low bias. All those things you need to know. And to avoid overfitting, all these parameters you need to fix upon this. And yeah, here we have something called hyperparameter tuning. Once I complete the thing, I'll just come into it. And once this is there, and bagging and boosting is there. So bagging, boosting. So there is ada boost, ada grad. I mean, sorry, ada boost techniques, and there are many gradient boosting techniques. Where what is a boosting technique? So there will be number of estimators that will not be parallelly run. Instead, a model will be trained based on this model's performance. The parameter will be given here, and different set of data will be taken, and it will be taken from the same bag, and it will be uh, taken out of 10 such samples. It will be sampled here, and this model will be trained. Again, this model is fed into here, and with that particular error and the correctness based on the error score, this particular model will be trained with different set of uh, randomly sampled data. So this is one important. Randomly sampled data is uh, one important thing. Sampled data. So all those things is what boosting is. And again, if I want to explain this, I need to go with the uh, uh, parameters only. I don't have anything much to say it as theoretically, because mostly it will be the same kind of thing. That'll You have estimators and n underscore estimator. So this is something called how many estimators. So how many kind of such sequence should be there. If I have 10 such sequences, I can say it as 10, and 10 such models will be trained upon. And there is something called base estimators. So what estimator that do you want as a base? And mostly this boosting technique have a same kind of base estimators. If I give decision tree, so all these 10 decision tree will be trained. So instead of, and this is not an efficient way of doing a decision tree. If I have 10 decision tree, what else can I use? We can go with random forest, right? Random forest classifier or random forest regressor. This is also one such technique of ensemble. Like, mm, yeah, again, I have to explain all the feature parameters only, so which is not efficient. Maybe I'll just go with some questions, and then yeah, and yeah, ensemble techniques are covered. And what is the error metrics? I just touch upon error and scoring metrics. So metrics is one important thing, because if there are like very few questions, like the weightage of these questions will be high, you need to properly align. So for classification, there is something called uh, confusion matrix, where you will be having a kind of this, where this will be true positive and this will be true negative, and this is false positive and false negative. I guess I'm right, and maybe I'm saying this as actual, and this is the predicted one. Predicted. Okay. So if it is that, this is how classification report usually confusion matrix looks like. And in classification report, you have multiple metrics where I'll just touch upon with the formula only. I'm not, if at all needed, I'll just solve any problems, and it's simple. So if it is precision, it is always true positive on the numerator, and for this it will be true positive and false negative. True positive plus false positive. So how I usually remember this particular formula is, if it is column wise, it is precision, and if it is recall is for row. So I'll remember that. So it is again always true positive in the numerator, and it will be false positive plus true negative. I'm sorry, I said it's true positive and false negatives. That's true positive plus false negative. Hope I'm right, because it is row wise. So this particular row is being on the denominator. So that is how I usually remember this recall and R. Okay. Yes. So, and there will be F1 matrix, F1 score, and these are scoring metrics, not error metrics. So what is F1 score? It is 2 into precision into recall by precision plus recall. So there will be definitely questions on this matrix. Yes, and what else? Error matrix was done. Yeah, any doubt till here? Anything that you want to ask? Anything that you want to say? Anybody, any questions? Okay, I'll just go with the next one. Okay, now I'll go with the questions. I need few questions, and maybe that will be more interesting, I guess.
Sir,
Yes.
someone is asking, can you elaborate how feature get selected in decision tree initially?
Okay, so there is no particular data regarding how it is being selected, because uh, it randomly selects features. So coming to the decision tree again, so it usually randomly selects the features. So randomly selects only. So based on some index, and mostly if you give PCA as a thing, the features which give uh, higher variance, that will be selected, higher variance. So you know how PCA works, right? So based on that, it will be selected, and that in sklearn there is different implementation. But if you do it theoretically, the nodes will be initially selected based on PC only. So once it goes little deeper, then there are other features, less important features, that is also being taken care of. And there are few techniques where correlation is being taken also. I've seen in one of the techniques where correlation matrix is being used for selection of this, and there are many internal features depends upon which library you use, and there are mm, you can change this also. Even in sklearn there is a parameter where you can change the initial uh, data, that initial feature that it is used to splitting the nodes initially. So yeah, does that answer your question?
Yes, sir. You can proceed with next.
Yes. Um, if at all any, yeah, I'll just give one question based on. Is the question visible? So simple question. I'm just giving. But this is one of the previous year questions. So can anybody solve this and say me the answer? What is the precision? You can just text also. It's fine. If you're shy to talk, it's fine. I just, yeah. If you have any doubt in previous year question, also just take the question and show me. I'll just solve it for you. No, how? No, zero point 0.5 is not correct. So these has, yeah. Initially, I've just said in this, if you have true, I mean, we have 0 and 1 only. There are only two classes in this particular classification. That is why this was done. But here we have three classes. So then how it is taken, and it is precision. It's true positive, and false positive. So we have three positive, and this is for class one. So we have to consider class one. 1 minute, sorry. Yeah, solve it. I'll just be back in a minute. Hello, bro. யாரு? ஹலோ. சொல்லுங்க. சொல்லுங்க. ரித்திகா சொல்றேன். Yeah, okay. Um, yeah, the last one is correct. Great. So, uh, which is true positive by true positive plus false positive. Right? So it is 2, which is this particular one, and true positive and false positive, which is the column wise. So this particular thing completely 2, 2, 4, so which is 2 plus 2 plus 4, which is 2 by, which is 1 by 4, which is zero point 0.5, sorry, 0.25. So like it might seem very easy, but this has good weightage on your item. So this particular question have 3 marks. That's too much actually. So you just need to know the formula. That's it. So yeah, maybe try with recall for the same label. Go with recall. This is precision, and yeah, tell me the recall. 2 by 6. Yeah, right. 2 by 3 plus 2 by 5, 6. Yes, right. Yeah, right. So which is, so anything similar to this will definitely be asked, like most probably. Uh, it's 2 by 6, right? 2 by 6, which is 1, 3. So yeah, and This is one simple question. Maybe I'll just see to any. Yeah, this is one good question. Uh, yes. Okay. What happened? I'm just restarting it once again. Is my screen visible? Okay. Yeah, start solving this question. Okay.
Sorry, are you sharing something?
Yes. Oh, is it not visible? Yeah. Oh, waiting. You could have said it. Yeah, this particular thing. Is it visible now?
Yes.
It is again a simple regression problem. I mean, recall score. You need to calculate the recall score. So yeah, how dummy classifier works, you most probably known if you have done the theory. It is actually every label is given one. So I have out of 650, one, and what is it remaining, which is 300, 350, 0. So if I run this particular model and I fit it, it will actually show me one for 1000 rows. It will show one. So then, what is the recall score? So it will be out of 650, out of 350 will be classified as, so the precision, the accuracy will be 650 by 1000, and this will be the accuracy. So based on this, you need to classify the thing. So who got the answer? Anybody? So before going to this, you just need to follow the, I mean, plot the confusion matrix so that it will be easy for you.
Yes, sir, can you explain once again? Did
Yeah, Yeah, what was the question? Sorry, I didn't hear you.
Can you explain the concept once again?
So,
650, it's in the 650, it's understood. The branch to
a
class.
feature matrix have 1,000 labels, 1,000
Rows.
rows and 5 columns,
Okay.
and Y has two classes only. Either it is 0 and it is 1, which is a classification kind of problem.
Okay.
And where 650 is 1, for
Okay.
650,
Okay. Okay.
yeah, and
Belongs to class one.
yeah. So, and now this is the question, and I'm doing a classifier. I mean, developing a model which is a dummy classifier where the strategy is most frequent. So, if it is most frequent, all the 1,000 labels will be classified as
It's one.
yeah. And so, if I fit it, it will be always one, right? So the score will always written on R2 score. I don't want the R2 score. I want the recall score now. So that is the first question.
Okay.
So if I predict X, then what is it? It will anyways give one only, right?
Yeah.
So everything is one, and so if we compare, it will be somewhere 650 over 1,000. That is the thing.
Okay.
Yeah, what will be the recall score then?
Okay.
Anybody wish to try with me? I'll just show the question once again. So, yeah, anybody who's ready can go with it. Okay, let me start with it. So 0, 1, 0, 1. So how many zeros and zeros will be correct, predicted correctly? 0. So this is actual and this is predicted. So this is 0. And how many ones and ones will be corrected properly done? It will be 650. How many zeros will be predicted as 1?
350.
350. How many ones will be predicted as 0?
No, nothing.
Yeah. So yeah, one thing that you can confirm is everything should be 1. So everything sum up to the proper, I mean, sum up to the data set completely. Sorry. So what is recall? Is equal to
650 divided by
true positive, which is true positive for the class label 1 only, right? So it is 650 divided by 650
plus
plus 0 plus 0 row, right? This one row. So it will be 1, right? All right. Any doubt? Anybody? Yeah. If any doubt, only I can go a little more deeper on this, or else I'll just move on to the next question. Yes, similarly, I'll just give a precision for anybody. So if I want to predict a precision of this, what is it? Same thing, precision. I gave the confusion matrix itself just for predict the precision now, for the class 1 only.
yeah,
Perfect.
650 divided by 1000.
Got it. So it is 650 divided by 1000. Yeah, it's 0.65. Okay, simple question. And this have like whatever the I solved has this has 3 marks. No, this has 2 marks. This has 3 marks, and the first one this has 3 marks. So around 10 marks is being confirmed for you, and the total exam itself is for 50 marks. And simple 10 marks you will get. So yeah. What else? Any other questions? Any good question? Anybody want to show up any question? Ask question. Yeah, this is one good question. It's a direct question, so anybody can answer this. Okay, maybe. Okay. Anybody? Because this concept is quite needed because
Okay,
leave one out is what.
and the 100 features. Okay. And for the class, leave one out to limit education, leave one out sport. First one, limit education is small. Leave one out. Post education, school, education features.
Yeah, you can answer. Simple answer, just one line, one word answer. So how leave one out class validation works. So basically, so 999 it will be trained upon, and one validation, one data point is used for validation. So similarly, other 999 will be taken, and one will be taken for validation. So if it continues, how many one I can take?
Nine
Sorry,
nine nine.
no, I can take 1000 itself, right? 1000 once I can take.
Okay.
Till x1 I can take x1000 also. X1 also I can take and predict, and x1000 also I can take and predict. So similarly it can take 1000 points. So 1000 times it will be models will be trained.
Okay.
Okay, and yeah, other one good question is,
So the
like,
answer is 1000, sir.
sorry,
And the answer is
answer is 1000. Yeah, 1000
okay.
is the answer.
Okay.
Yeah, this one. Yeah, it would be better if everyone answers the question. Even if it is wrong, it's fine. You can speak it out. Yeah, solve this question. This is similar kind of question, not similar. It is one important question maybe. So how grid search CV works? I just with this context, I just say how grid search CV works. So if I have two parameters and each have three possible values, then how many possible combination it will have is 3 into 2, right? So all, I guess this is kind of a matrix. So 3 cross 2, 2 cross 3 kind of matrix it will be created for grid search CV. And randomized search CV, you can give a distribution np dot random np dot lean align. So lean line. So all these kind of things also can be given. So or np dot normal. So all those things can be normal of 0 comma 1. So some kind of distribution can be given in the random forest classifier. Sorry, randomized search CV. Randomized search CV. Whereas in grid search CV, so any kind of this matrix can be given. So yeah, coming to this particular question. So how many such combinations? So grid search CV 3 cross 2. There is 3 and 3, 2, 5, 5. So and this has two dictionaries in this particular parameter grid. So then how many unique combination will be trained? So that is the question. Yeah, I'll just give 2 minutes or try to solve it. Any questions, anybody? Okay, I got the answers. 5 into 3, 3 into 2. No, the multiplication will not be happening. So the thing is, this is one important. That is why I just took this question, because there is two dictionaries involved. till here one dictionary, and this is one dictionary. So which is in first dictionary it is 3 and 3 plus 2 5. So it is 3 into 3 5 are 15. Similarly, it is 2 and 3. 3 2 are 6. 2, which is 6, and it will be 21. And this will be an addition because we have two different. So this will be multiplication and this will be separate multiplication, and the addition will be the answer. So most of the previous questions, if you take, there will be a lot of questions like this. Yeah, maybe you can focus on this. Is everybody clear with this question? I hope yes. So I'll just go with any other question. Sorry.
Yes, sir.
Yeah. Yeah. This I lock, I lock. All these you need to be knowing. Um, let's take any good question. Yeah, and then one more thing. There is something called chunk size. Chunk size. So if the data set is like 100k rows are there, we can chop it out and we can give 124 per time per time. So so we can give the data chunk wise. So it will be loaded. So this will be for loading purposes. We can every 124 and then again next set of 124. So it will be randomly done over here. So that is where chunk size comes into, because we cannot load a large data set directly into our collab. So some kind of this loading can also be possible. So that is something like this. And I've said what is C, and yeah, and what is epoch. What is epoch? And if I want to set it in my thing, it is known as maxiter. So anybody want to know what is, like, anybody knows what is epoch or maxiter? What is one epoch? The first two, these are like, it might sound simple, but there are questions on this also. So which is since no. So epoch is something. No, no. Yeah, this computer. Epoch is something. Uh, one run to over the data set. So if I have 1,000 rows, if I see all the 1,000 once, then it is one epoch. So if I set max iter equal to 5, this 1,000 data points will be seen 5 times. Okay, 1,000 data points will be seen 5 times. Then it is 5 epoch. So these might sound simple, but these are very important uh, terms that you need to know. Okay, and all those things. Yeah, if you have any doubt only, it will be easy for me to actually go with some topics randomly. So if I start explaining from the week one, it whole day will not be enough. Um, yeah, I guess count vectorizer is there. Uh, See, there is one question based on this. Paste. So high variance, low bias. So what will be the answer for this? Anybody? Just now I taught what is decision. Decision trees are prone to what? Sorry. Yes, tell me, please. Will that be?
Forward shifting maybe that's that thing. Mm.
Yeah, just now I said, right? So it has high variance
And,
and low bias. So if it is high variance, if you know, you definitely there will be low bias. So this is a trade-off between that. Yeah, these are simple questions, but this has 2 marks. So make sure everybody concentrate on these particular things.
Sir,
Yeah, yeah, yes.
Harshit wants you to repeat epoch.
Okay. Uh, Epoch. Yeah, here epoch is something that you see a data set, complete data set once. If you see run through the entire data set once, it is known as epoch. If I have uh, 10, 10 rows, if I see all the 10 rows once, it is known as one epoch. So if I set max iter is equal to 5, this is seen 5 times. 5 times the same 10 data set is seen. Then it is known as 5 epoch. Okay. So that is it. Maybe anybody who's joining again, try to join with your official mail ID. And yeah, this is again simple question where you are given a param grid and we need to fill this. So what is the parameter that is inside polynomial features? What is the polynomial features? So ax square plus bx plus c, right? So if it is 2 here, then it will be the power will be 2. So then what is this? What is the name of that particular parameter? So usually questions will be like this only.
Degree.
Uh, this is one again good question. So it is poly. If I am doing it as a polynomial uh,
Degree same somebody answered.
features, yeah, I'm coming. If it is degree only, you're right. Degree is equal to 2. But here it is inside pipeline, right? So if I want to uh, get into the pipeline and change the parameter, how do I want to? How do I usually do it? So these are some first 4 weeks question only. How do I want? How do I do it? If I want to enter into that particular exact, it will be poly double underscore degree, right? So that will be filled here. Here x will be here. Getting it? How poly underscore underscore 2 underscores will be there. So that is how you need to get. If I want to SGD, if I want to SGD, then I want to go SGD underscore underscore and whatever the thing is loss. So I can change the loss like this. If it is inside pipeline. So this is very important thing. I'm sure that since there is no doubt, I'm assuming that everybody knows this because these are basic things that you should know at least by now. So it is almost in term you need to know.
So that is there in the we have to fill like x uh, equal to poly underscore underscore degree.
No. I'm just putting x. Okay, it creates confusion again. So x is not. I'm not saying x. Here I need to something. This should be filled over here.
Okay. Okay.
Poly underscore underscore degree should be filled there.
Okay.
Okay. So if I want to have another thing, we can add SGD, and this poly and SGD comes from here. This poly and SGD. If I instead of SGD I have GDS, then I have to put DGS underscore underscore loss. Okay, so whatever the key name, this is the key name, and based on that key only we can access anything inside the pipeline. So these are very important things that you need to know. Okay. Yeah. Any other questions? Yeah. I'm assuming that everybody knows this. That is why I'm skipping. If it is any questions only, I can go. Okay. Yeah, SGD underscore. I mean, SGD regressor have something called penalty. Or anybody know what is penalty? L1, L1, L2, last one ridge. Which is last one? Which is ridge? Anybody?
L1 is lasso and L2 is reject.
Sure.
L1 is
Yep. You can refer and save also. Fine. And this comes for penalty. Okay, so penalty, the parameter that is used inside this penalty. So for all these, I don't know if at all any doubt only I can answer, but there is inside penalty. If you give L1, it is lasso, L2 is ridge, and what else? Elastic net is there. Elastic net. What is elastic net? It is a combination of L1 and L2. So these are important things, and there is even in L1 and L2 there is one other parameter which is called L1 ratio. L1 ratio, where you can in elastic net where you can set what weight it should be L1 and what weight it should be L2. So these are very important things that you definitely need to know.
L1 is lasso, sir.
L1 is lasso, right?
Yeah.
Right. And L2 is ridge. So basically it will be ridge only for lasso. I mean for SGD regressor. So these are penalty that is being given, and there is loss parameter. Yeah, there are a lot of parameters involved in this particular SGD alone. So SGD is one important question. There will be definitely questions on this. You can refer to documentation for every uh, questions, every possible question that will be asked. Yeah, this is one important question because there was one question in previous year also regarding penalty. And what is it? Mm, I hope I've covered most of the top, not most, at least partly I have covered. Yeah, and yeah, this is one important thing I missed. This is HDD, and coming to voting classifier, I said something called hard and soft. Voting classifier. So there is something called hard and soft. Hard, if I have three estimators, and two is giving zero label, and one is giving one, then which one will I choose?
Zero.
Zero. That is hard voting.
Yeah.
So for soft, it won't give zero or one. It will give 90% zero and 10% it is one. And this is the first model that will give. And the second model that will give somewhere around 80% it is zero and 20% it is one. So similarly, there will be two. What I will do is I will add all the things 0.6, 0.7, and zero point 0.3. I'll add all these three 0.9 plus zero point 0.8 plus 0.7 divided by 3. So that will be the probability. Uh, so it will give a probability score where I add all these and divided by 3, whatever the answer that comes, uh,
0.8.
that will be given.
0.8. Yeah.
That will be selected. So whichever is higher, that will be selected. Yeah, I'll just give 2 other minutes. Try. Okay. Am I audible?
Yes,
Yeah.
sir.
Thanks. Mm, maybe I'll just share the entire. So, okay, so there are questions like this where voting classifier is being asked soft margin. So, as I said, what is soft? Final prediction are based on average probabilities predicted by each classifier. So that is how this soft works. Hard is something that is a weighted sum of. Yeah, I guess I can write on this.
The first one is hard, no, sir?
Yes, exactly. You're right. Yeah, good catch. So first one, the first option belongs to hard voting, and this one is for soft voting. Weighted sum, these are different. Yeah, and cross validation, all these things. Packing classifiers. Yeah, so if at all any doubt, I can go with it. I guess I've said few important things. So any doubt, you can go with it. Any questions, any doubt? Okay, that's it from my side as well. Like, uh, if at all any concept that you want to discuss or any doubts, if it is there, then I'll go with it. Or else I almost said all the important things that you need to learn. Basically, so yeah. Any general doubts, anything you can ask. It's fine. Any course wise, it's almost course is over, so you can go with it.
Sir, what is that parameter underscore dist that is in dictionary std underscore underscore alpha 0.01 0.1 and that is learning rate.
Which one? Which one? Where it is?
It's a question paper.
Can you share that?
Uh, Here one question is which of the following pipeline implementation? Can you see this one, sir?
Yes. Okay, so regression is operated with randomized search CV for hyperparameter training. Okay, so okay, it should actually go to SGD regression.
Yeah.
Yeah, this is one good question you could pick.
Pipeline scale up and STD. Okay.
So what do you think? Which one is the right answer? What is the question actually? What we need to find?
Uh,
Using STD with randomized search perform rinse rate.
Critical regression using
Yeah.
stochastic STD
Okay.
with the
Easy.
random search
Yeah.
tree.
It's an easy question only. So yeah. Which one do you think it is right?
Picture regression. Picture regression. Level 2.
Second option? Sure.
I think so, sir.
Why not third?
Pardon, sir? First
Why
one.
not third option? No, why not third option?
Third option. Penalties. Okay, L2 is there. So that is ridge only. Okay, okay. Penalty.
No, why not? There must be some error in the second. Is there any second?
No, no idea, sir.
One minute. Oh, there is no difference at all, right? Inside.
Yeah, yeah. Penalty also L2, L2.
That is right. SGD and SGD is also correct only. Yeah, almost everything is right only. Show me the fourth option.
That is ridge.
It is Ritchie. No, no. They are asking for ridge classifier only. So go above, go little above. Yeah. So which is this one? The second option is SGD regressor, and third option is SGD classifier. What is the question that is being asked?
They are SGD.
Ridge regression only.
Yeah,
It's
yeah.
regression. So it is SGD regressor. Second option is actually right. SGD regressor with L2, right?
Yeah.
Yeah.
Okay.
What is the answer? What is the
Yeah.
actual answer? Is it right?
I don't know, sir. Yeah, correct, sir.
Right. Yeah. Anything. Yeah. Any other questions like this? Can anybody show it up? Ask me. So if you start solving all the question papers and just get an overview of the documentation, though, if they are asking for a SGD regression, just open the SGD regressor documentation and start learning all the parameters. It will actually give you a best idea of what is being asked itself. Most of the questions will be based on that only. So if you start learning all the documentation, see the slides, and if there is any models or any kind of thing that is being asked, go to sklearn, see the documentation, you'll get to know everything. So that's it, very simple. And theoretically, it is very less and very easy. One course that you can easily score upon. Yeah. So yeah, yeah. Go ahead with any questions, anything.
Guys, if you have any questions, please ask.
Sir, can you differentiate between that P equal to 1 Manhattan distance and Euclidean distance? Um,
Okay.
Check the
Was
similarity.
it
Some
Manhattan distance is some Euclidean distance is the x2 minus x1 the whole square plus y2
yeah,
minus y. That
some
is Euclidean distance. Okay, so Manhattan distance is also okay.
absolute,
Coming,
but some in the code it is saying like P equal to 1, something for Manhattan, I think, and P equal to 2 for Euclidean.
do you have any questions regarding this? I mean,
Yes,
any
yes,
questions you show?
let me see that.
Yeah, Harshit Tiwari, sir. Whenever you will, morning, or madam, you don't think so. No, not necessarily, but if you want to build a complete project, MLP project, it is better that you know some mathematical background behind the model that you are using, the pre-processing that you are using. If at all it didn't give you a proper score, you will know how to rectify that. So that is how actually you will progress. Or else, or else it will be an uh, trial and error method only. You try this model, randomly switch to some other model. You don't have any guided way of going up. So if you want some guided, then you need to know what max. I mean, mathematical background behind that. Okay, you mean okay this one. Mm-hmm. What will be the output of the following program? Zero. And neighbor classifier. Zero zero. Coming to this, no, neighbor is 3 is fine. What is the answer? Last one or okay, okay. One minute. It is the effective metric. AMC question is effective metric. Mm, 1 minute. I'll just check on what is effective metric. Distance between metric, parameter. Okay, so that is because what is effective metrics is basically the p. If it is set to 1, it means it is using a Manhattan distance, and if it is 2, it is Euclidean distance, and if it is any p, then it is Minkowski distance. What is Minkowski distance? Is a weighted sum of the weight. I mean, weighted sum of the each points. If it is very large, if it is very far away, it will be given less weight, and anything which is closer will be given a little more weight. So that is how the Minkowski method actually works. So if I set p somewhere around zero point 0.5, so it creates a circle kind of thing where it will be weight based on weights. It will be given the I guess so. So that is how it usually works. So yeah, maybe you can check regarding this effective metric. But the effective metric, since it is p is equal to 1, then it is Manhattan only. So if you refer to the documentation also, it is actually showing that only.
Okay.
But these are very rare questions. You cannot memorize which is 1, which is 2 and all. It's fine, yeah. Any questions? Yeah. Any other questions? Hmm. Yeah. But okay, then I like starting it was 36 and it's 17 only now. It's fine. Okay, so if at all there is no other questions, we'll wrap up the session for now. Any other questions?
Yes, sir.
Yes, please go ahead.
From the same question paper, I have one more question. This grayscale, this one, sir. Can you explain a little bit about list this, this concept?
Okay, okay, yeah, yeah. That means had it in the so the first option is right only, right? So what doubt do you have in this? Because so how this MNIST will be there is it
Mm,
has uh,
and how the what is the means how it works actually? I missed it.
MNIST is a data set where uh, uh, MNIST is a data set which has 0 to 9 photos. It is an image recognition data set where you will be given some random kind of images, and there it will, in that images there will be numbers present, and there will be white background, and in black it will be written some of the um,
Lectures.
yeah, yeah.
Yeah.
So what this particular question is asking is which pre-processing step is most essential for improving the performer of an MLP classifier on the dataset. So, uh, so if at all it is a classifier recognition dataset. mm, MLP classifier. So since it is a classifier, it is better that you convert images to grayscale. So images will have a matrix kind of representation. If you convert to grayscale, it will be linear, right? So we can feed it into an MLP classifier. So that is how it is done. To convert images. Images is something, some x cross x. So if you flatten it in 784, grayscale images, it will be 0 to 225, right? Every cell will have either 0 or 255, any number between that. So that is a grayscale image.
Okay.
So if we convert that, we can have a proper grayscale image, and it can be fed into an MLP classifier. So you know how MLP classifier works? It is a neural network kind of hidden size input, all those things. It's fine. When it is in the last week of your slides, you may refer to it.
Okay.
Is any other questions from any other buddy? Like anybody else want to ask any questions? No. I don't know why like very few people only asking. How about others? Is it clear enough, or is it still uh, any questions? Anything that you still have doubt? Is it not good that much, or any sort of suggestions? Anybody have? Okay. Yeah. We'll go with any other questions. If there is any other question, we'll go with it. Any questions? Anybody? Okay. If there is no other questions, we'll wrap up the session, and it's almost time, I guess. Hope I've covered mostly important features. I'm not sure since there is no other answers. I'm still confused how good it was. Yeah, whatever I know and whatever the tricks I used was here, and I understand that it is quite a little more earlier, like it is 1 week ahead of this. I mean, 1 week ahead of Entom. So most people might have prepared on this, but it is an easy subject to boost your CGPA actually. So concentrate on your Entom. You'll definitely have a good score. Any questions?
Will there be any other sessions later on this?
I don't know. It depends on uh, the secretary members only. So as far as this particular week is concerned, only one only it is being scheduled. If at all needed, we can take one other session also. It's fine.
Okay.
Yes. Any questions? Anybody? Okay then. Yes. So much for the wonderful session. Thank you so much.
Thank you so much, sir, for joining us and for your wonderful session.
Thank you.
Thank you.
Thank you.
Thank you, sir.
Thank you. Thank you so much.
Guys,